Welcome, everyone, to this Professional Development Hour presentation brought to you proudly by the Atlanta Metro chapter of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. This presentation is brought to you tonight live from Wild Wings Cafe in Dunwoody, Georgia. Before we begin, we'd like to let you know that any opinions presented tonight are solely the opinions of the presenter and not that of the Georgia Society of Professional Engineers, the National Society of Professional Engineers, or any other of its affiliates. We certainly hope you will enjoy tonight's presentation, so sit back and relax. And on with the show.
Go ahead. All right, folks, we're going to get started. Sorry for the little delay, little technical difficulty. Couple of reminders, please make sure you turn off your phone. Second, make sure you sign in. We have a door prize after the presentation. All right, so without further ado, today's presentation is going to be on plastics recycling technology. And our presenter speaker, Jeremy Daniel, please join me in giving Jeremy a big, warm welcome.
Thank you. I want to thank Roger for inviting me and everyone here at the Georgia Society of Professional Engineers for having me. Great group of guys. I guess I'll just start off with my background. So my family's been in the industry since 1972. So they were all sitting around watching the movie The Graduate, and they said plastics is the future, and so they all got into it. Actually, our company, the original company that I started working at was a family-run business, and they were kind of one of the four runners in the plastics recycling industry, mainly in the polyethylene, so the trash bag industry. And so one of the partners worked for Mobile Chemical in Macedon, New York, and they purchased the first pelletizer. So a pelletizer is basically, it's at the end of extruder, you got a polymer melt and it goes through a die that has holes, right? And it goes through like a spaghetti, and you've got cutters that cut it into plastic pellets. And so they were taking printed film and converting it to pellets to use it back into making trash bags. So that's kind of the beginning, and I started working there at 1988. So I started out running grinders and shredders and guillotines, and I'd get in trouble and they'd make me mop the floor and all kinds of stuff when I was a teenager. So I want to kind of go into, what is recycling, right? What is plastic? The terminology in the industry is plastic scrap. So it's a waste or byproduct in the plastics industry, right? It can be post-consumer, post-industrial, post-commercial, right? So your post-consumer is something that comes from you being the consumer, meaning that's your curbside, your single stream where you put it in the container. And the post-industrial, here, I'll go through here. So first we'll go through the post-industrial scrap. So post-industrial is from an industry manufacturer that is making, we'll use plastic bottles or trash bags. Everyone knows what trash bags, so I'll use that as an example. So in your trash bag, it's a blown film process where they've got a die that oscillates. It's a round circular die, and they extrude material through it, and they blow air. And they blow this air tube that goes all the way up into nip rollers, comes back down, and they have rollers that create gauge in the film, so how thick the film is. And of course, if you buy any trash bags today, you realize those bags are really thin these days. Years ago, they used to be nice and thick, and you could put all kinds of stuff in it. So a post-industrial scrap is, there's always going to be errors There's going to be trim scraps on the sides. There's going to be waste that comes from the industrial side. So the thing about post-industrial scrap is you kind of have known parameters. You know what the material is. You're buying it from the company that's manufacturing it, right? So you don't have as much testing. You kind of know what the specifications of the material is, and reprocessing that or reclaiming that. So there's two terminology in our industry. One is reprocessing, and one is reclaiming. So a reclaim, when we talk about reclaiming, it's mainly comes from the post-industrial field, right? Because you're just reclaiming the raw material that was originally used. So some of the issues that have with the post-industrial is they normally come in large industrial rolls, or they come in large, thick sheets. These are finished goods or errant goods, and they're large, bulky pieces. So they're not little bottles, or they're not little things like you get in your curbside. So you've got to have industrial equipment to be able to handle these large pieces. You have to have guillotines to cut the rolls, or you have to have shredders and grinders to do the size reduction of the materials. When you're processing a post-industrial waste, since it's a known quantity, we know what the specifications are, we know where it's coming from, and this material has never been used, right? So the contamination level in it is very light. So you don't really need any type of, industry, melt filter. You just need a basic, what they call a slide plate, which is just a screen like this that's similar, and the melt comes through the screen, and the plate just slides. They tear the screen off, and that's it. So there's not much. The level of contamination is less than 1%. The next one's going to be, and I'll kind of jump around. The next one's going to be landfill diversion. So here, let's go through this. Let's go to post-commercial scrap. So you have post-industrial, and then we have another large feed stream that we call post-commercial scrap, right? And post-commercial scrap is where an industry has used the product. So instead of you consumer, a bottle or a shampoo bottle, the industry used it, okay? A good example of that is we used to process and purchase material coming out of Budweiser. So Budweiser, when they have the bottles that sit on the conveyor belts, it's a nylon conveyor belt, right? Well, it's not a belt, it's a nylon, it's interlacing pieces, and it's all nylon. And every year they would pull every one of those nylon conveyors out and recycle it, and it would be close to, 60,000 pounds, 2 truckloads of material. And so it's good nylon material. So that would be an example of a post-commercial. Another example would be, plastic pallets. So if an industry is shipping from, say, the automotive industry, where they're shipping motors, they're going to have crates that are all plastic, and they'll put these motors, or they'll put, exhaust or whatever it happens to be, and it'll get damaged. And, that is kind of a post-commercial stream. What are the benefits of post-commercial stream? It has known parameters as well. We know what the material is. It's coming, if it's a crate, it's a crate. If it's a, pipe that we get out of the ground. So a lot of times when they're pulling up pipe, there's a extruded pipe in the ground. They'll pull that pipe up. We know what the pipe's made out of. The issue with post-commercial is we start getting into a need for additional processing, right? It's not just an extruder and a slide plate screen changer. If we're dealing with something that's already been used, you're going to have inherent contamination, right? You're going to have your scraping it off the ground. You're going to have metal. You're going to have stickers that are affixed to the side. You're going to have paper. You're going to have tags. So we've got to create a scenario in which we can convert that material back into its raw material, which is a finished pellet, right? So we've got to add additional steps to be able to process that material to get into that same raw material as your post-industrial. Most of the time with the post-commercials, you don't necessarily need to be a full wash and dry. You don't need to submerge it. You don't need friction washing. It normally can be handled with a melt filter. So, and I'll show you some photos of a melt filter, but this is a screen from a melt filter that we sell. So this is a 400 micron, it's a laser filter. So the holes were perforated by a laser. And it's got a conical, so it's larger on one side than it is on the other. And so to handle the paper, the metals, all you would really need, in the industry is to use, a melt filter. And I'll show you some photos of that, but we'll get through the different types of materials. Oops. The next raw material is landfill diversion, right? So, and this is kind of a topic that I think that a lot of times has developed into a good source of raw materials through the technologies that have come along for us to be able to use these materials. Mainly it's agricultural film. So things that have been in the ground. Normally it's a film, it's a 1 to 2 mil, it's thicker. They use it for weed abatement, and they lay these agricultural films down for farming. And so when we take these films up and drip tape, so similar, drip tape is just going to be more of a rigid pipe that they use. It has perforations that they run it in these fields to irrigate the crops. And so when you pull these materials out of the ground, you're going to have mud, you're going to have embedded rock, you're going to have pesticides. So and historically, those have all just been, at the end of the year, they pulled them all up, they threw it in the trash. So there's been a boutique industry that's kind of come after and has understood that that's a large volume of material, and they've developed technologies to be able to handle that. Other historical landfill diversion materials are going to be your e-scrap. So your electronics, whenever you turn in your old, flat screens or your old computers, obviously they're getting a lot of metals out of that, but they're also getting a lot of high-grade engineering materials, your polycarbonates, your ABS polycarbonates. These are engineering grades that carry a lot higher price than your fundamental, polyethylene or polypropylene. So, with these, landfill diversion, the products that's kind of developed over the years have been, one of the main one is optical sorting. And believe it or not, the optical sorting has come from the food industry. So a lot of the optical sorting for grains, rice, they want to spot on a high rate, they want to spot what are these rice or these grains that have gone bad, and they use a camera system, and they disperse the material through these trays, and through air actuated pieces that are tied to the cameras, they can blow out the bad materials. And I've got some pictures of that as well. When we're dealing with landfill diversion, this takes a lot larger investment and a lot larger additional equipment that needs to be able to handle these landfill diversion materials. One of the ones that I'm in a current project with in Canada is the ocean. So the ocean debris. So right now this company is pulling out all the nets, so the nylon, the propylene netting, the rope. So one of the key issues with the with the rope and the netting coming out of the ocean is A, it's got salt in it. Number two, most of it's hygroscopic, which means it's absorbing moisture just by being there. And so those are kind of two key things that kind of have to be taken into consideration to be able to convert that material back to its raw form of pellets. So, you know, and I guess I'm using that term raw material pellets. You know, all these processes, the end material we want is going to be a pellet, right? It's a known bulk density. It can flow through your pneumatic systems to be able to feed into your, you know, injection moldings. You're drawing it out for, you know, fiber, or you're making sheet out of it. So, the kind of industry standard is to get it back into that pellet. Some of the industries you don't necessarily need to have pellets. It can be in just a what they call a regrind, which is a 1/2 inch ground material. So it doesn't have a uniform shape. It goes through some grinders but the you know, the regrind can be used in some industries.
Could I ask a question?
Yeah.
This has to do with vinyl records, okay?
Okay.
And it was said, maybe you don't know, but I'm curious, especially when vinyl was the way we bought music, some record companies, in an effort for economy, if records didn't sell, they would regrind them. And it said that the audio quality, the noise on the discs was worse because it was regrind. Do you know anything about that?
Well,
the only thing you would have is the paper labels on the record itself.
Yeah, I mean, the paper labels really wouldn't be an issue. Mainly what you would have is, you know, you've got with nylon and PET, you've got a viscosity. So you have a relative viscosities. And anytime that you're introducing something, you know, a material that's not your prime form, right, you're going to have a fall off and or increase in a viscosity just because it's been heated additional times. Plus you're going to have one of the big key issues is going to be oxygenation, meaning that it's absorbing, it's got oxygen in it, it's starting to kind of oxidize. And those records, I believe, had an issue with oxidation, and plus stabilization, and there's a couple of things that that could impact taking one product, grinding and putting back in the same product. And I'll give a quick story. So I was somewhat involved in a large bottler and soda company here in Georgia, and so they wanted to use start introducing regrind, or wanted to introduce PET, recycled PET, back into their bottles. Right, and so, okay, well, we started collecting the bottles, we went through, we processed it, and what they found out is this, you know, the material that we came out was a solid state. It could be used, it could be blown into making another, you make a preform, and in the preform you blow the bottles, right? And so we made good quality preforms. Unfortunately, with the drop in the IV, or the relative viscosity, the molds that they had were not designed for recycled viscosities. They were designed for the prime viscosities, right? So all of a sudden we've got all this, you know, material that we converted, and they didn't have the molds. They've since, I don't know if you've seen the new bottles out from said company, but now they're using the recycled content because basically they had to retool all their finished product equipment to be able to handle the drop in the IV, which it was just a tool design. So, you know, as long as, and I think that's in this industry, I think a lot of that's kind of started to be accepted, to understand that you know, as long as we're making an effort to do this recycling, as long as we're making an effort to try to make it end product, because that's the basis, you know, the end product is what drives the market. Right, because our industry, you know, in Europe, a lot of the industry is subsidized. So in the United States, very little is. There's some that in some industries, but primarily it's profit-based driven. And you know, if you can't, you know, make that product for a profit, then they're not going to make it.
What about mineral or fiberglass or even wood powder additives?
I mean, wood flour additives. Okay, obviously there's in the decking industry. The wood flour is, it helps lighten the load. So, if you take a straight polyethylene, most of those boards are made out of polyethylene. We use Trex, for instance. Trex used to be a mobile chemical plant up in Virginia. We were one of the first people that sold raw materials to Mobile Chemical, and they sold it to Trex. And I was somewhat intricate in that formulation that they were using. The problem with, using certain additives is you've got to have that end product first, right? And so as far as designing equipment, and I'm not quite sure exactly what your question is, but as far as designing equipment to integrate, things like wood flour, things like, right now there's Lehigh Technologies that's right here in Tucker, takes the chrome rubber out of the tires and they grind it to a small particulate as an additive into other polymers. So, these are, as long as, from an additive standpoint and being able to use products that are, deemed, wasteful. As long as you're designing the equipment and you understand you have an end product, most of the design of the equipment can be made. Does that answer your question?
Well, if you've got a material that has fiberglass, but yet the producer of the product doesn't want fiberglass top in his plastic, obviously that's not going to work.
Right.
And how do you control that?
Right. So, I mean, so in our industry, you have glass fiber or reinforced fiber polymers, right? And then you have a fiberglass coated materials. So let's call it Yamaha down here in Noonan. They made two different products for their ATVs. One was a standard TPO, the other one was a TPO with a fiberglass to help reinforce. That's not, that material is not an integrated material into the polymer. That's a laminated piece on top of the polymer. And so the glass fiber is not something that could be, integrated into a finished good. I tried. So the fibers are too thick. The adhesive that they use, and it's acrylic adhesive, there's just too many variables. I mean, and I guess when we get into recycling, there is a scenario where you have to minimize some of the variables, right? I mean, obviously there are things like compression molding, right? So you could take, let's say you're making a big wire spool, right? That you could possibly, take that material with the fiberglass, warm it up. You're not extruding it, you're just warming it up and then pressing it into a mold. Sure, it can be done. But, anytime you're dealing with, my experience, anytime you're dealing with glass fiber of that sort, right? As soon as you try to size reduce it, what happens to that glass? It gets airborne, right? And so all of a sudden now you're dealing with something that's, can be hazardous, whether it's breathing, whether it's eyes, whatever it happens to be. That's something you have to take in consideration. All right, here. All right, so we'll go into the post-consumer. So processing a post-consumer, mostly it comes from the single stream curbside, your local municipality, your drop-off points, material return designation collection boxes. I want to kind of key on that one, okay? And I think this is, we always like to hear success stories, right, as far as recycling and how this circular economy is really happening. And so there's a large grocer that all their food bags and their grocery bags, right, they've got drop-off points inside. When you walk up, you can put the bags in the box. So there's a company that makes those bags, right, that takes that film They bale it up at their distribution facility. They send it back to the blown film operator. He recycles it, pelletizes it, puts it back into the same film that gets eventually sold back to the grocer. And that's kind of the real, you know, those bags, believe it or not, are one of the most recyclable materials there are. Right? It's a commodity type resin. It's an LDPE film.
How about PET milk jugs?
HDPE milk jugs? Well, HDPE milk jugs is the most recyclable material, and there's issues with milk bottles. So as far as addressing milk bottles, the problem with milk bottles is it's too high a demand. Okay, so right now, current market rates for HDPE prime resin is roughly about 45 to 48 cents a pound, right? Recycled content HDPE blown film, blown bottle repro, PCR, is going for about 89 to 92 cents, right? 2 years ago, during the middle of the pandemic, that price went to $1.80 a pound. They were paying over $1 a pound for baled bottles, right? And meanwhile, the resin price was half of that, the prime resin price. So there is some scenarios in which, you know, us as consumers, and if I'm put my consumer hat on, you know, all of a sudden, do I want to pay 3 times the price for a recycled good material because it's got HDPE? And
Go back then, the price of aluminum cans, aluminum soft drink cans shot high.
no, everything did during the pandemic.
50 cents a pound.
Yep. So we all understand the PET bottles, PET food trays. Those are what you put in your curbside. A big key one that I'm really hot on is all the polypropylene. So, you know, this is kind of a new one that we're really trying to get some traction. That's mainly your yogurt cups. There's your PP straws, believe it or not. You know, don't use straws, we're going to paper straws. But the PP straws, you know, and PP is a very recyclable product. There's a huge demand for it. You know, and as far as, you know, I'll go in a little later about standardization of materials. You know, I really would like to see, you know, certain materials that, you know, as far as the polypropylene and certain products made from polypropylene, and I think that whole recycling of the polypropylene, you know, has a big upside. Right now, it's probably, you know, 2% of total recycled materials is a polypropylene, but we're really trying to push that up, and we're truly trying to kind of target that at the MRFs, so the material recovery facilities. Some of the issues with post-consumer is you know, your detergents, your oils, right? Your organics. Right, you got to get rid of those things. So that kind of goes, there's a whole level of washing and drying that needs to happen, and I've got some slides here that I'll show you. But you know, those organics, and there was a question was, you know, what do I need to do, you know, to my materials, you know, before I put them in the bin? And obviously, it's nice to wash them out. They don't need to be spick and span. I mean, they, you know, they're going to go through a lengthy wash and dry system. They'll probably go through an odor abatement system, which means that, you know, when you go through and you have organics and it's in, you know, a post-consumer or trash kind of, you know, receptacle, it's going to have inherent odors. Right, and so the current technology is you know, for these odor abatements it's a system or a vessel in which the material sits in, right, and there's a time and temperature. So it sits in this vessel, it's kind of slowly warmed up, and it just kind of sits in this vessel, and it allows that polymer to open up and release all the gas and all the odor, and that's how they're getting in a lot of the you know, food grade, you know, applications. That process is how they're getting it qualified for a food contact recycled good. Those commercial scrap. All right, here's just some examples of the ag film. So this is ag film chunk. So most of this ag film that we talked about, pulling it up off the, the farms, they run it through these machines, and this is the purge out that comes through it. So, and the other one is a PET strapping. So the strapping that they use to tie down pallets, things of that nature, that's the lump and chunk. So let's, all right, so we were talking about the fish nets. So this is a project I'm working on. Well, second half of this, so they're upgrading some of their systems. So this is a fluid bed dryer. Oops, sorry. This is a fluid bed dryer. So basically, it's material is introduced at one end, right? You've got hot air that's blowing through, and it's perforated, and it's at an angle, and so the material kind of shakes. And that's same scenario, it's time and temperature. So the hot air goes through, you got an exhaust at the top, and this material, this dries the nylon, that's actual nylon netting from the fishing industry up in Canada. So then once that material is dried, then it can be conveyed into the extruder to be pelletized. One of the main issues with, hygroscopic materials like nylon is that it's got moisture, right? And what happens whenever you begin to process nylon with moisture, as soon as it hits that wetted surface or any type of heat and it starts to flux or melt, that moisture wants to escape, right? And you create pressure. And, polymer pressure we can handle, humidity and water gas, right, becomes an explosive piece basically. So anytime at any area, the easiest way out's the way it's going to find. And normally polymer will just, it'll splat polymer out. It'll, through your dyes, through vents. And so we really want on these these hygroscopic materials, you really have to dry them to even hope to pelletize it. Here's an example, two examples of the optical sorters. So the resin would come up, or a regrind would come up at the very top. There's eyes that are cameras that are mounted within the baffles, and as the material's got little levers, and as the material falls through at a certain rate, it'll kick the materials out that it doesn't want. So you have two different ways. You've got an infrared, where it actually can scan the polymer and say, hey, that is polyethylene, that's polypropylene. And or there's color sorters. Basically, you've got a color background or anything that's that it kind of falls through, and it'll accept or discharge anything that's not that color. The second one is on this side right here is that is a bottle sorter. So same basic concept. You've got a conveyor belt that has the spreaded bottles, PET bottles, and as it goes through the conveyor, it's going to fall, and there's air actuated that's tied to cameras, and it's going to give a little puff of air. And it's going to send that bottle to whatever direction you want it to.
How big is the thing on the right?
I'm sorry?
How big is the thing on the right?
Well, normally they'll stack them. So this thing is probably, as tall as this top of the ceiling, and it's probably about, each one of these panels is probably one of those panels. And so what they'll do is they'll stack them one next to each other, and depending on the rate, whether it's, this machine I think does roughly 500 pounds an hour. So, most of the recycling systems kind of operate roughly at around, 2 tons an hour. So about 4,500 pounds an hour. So you would just stack them, and you would just disperse the materials across, the belts or pneumatics or however you want to space out the materials. This is kind of your wash systems. Okay, so The one on the left, on the right is your, see, I keep pointing, is what's called a friction washer. So the material is inputted at the very bottom of the washer. Inside of it, it's a big centrifuge, and it's got angled pieces that are inside this tube, similar to your washing machine, right? And this tube, it's going to spin, and depending on what you're looking to clean or what you're looking to, remove from that feed source, is how those baffles are designed. So if you're trying to, remove dirt, or if you're trying to remove dirt, that's designed a certain way. If you're trying to remove rock, that's a certain way. If you're trying to remove paper, that's another way. So, your paper is going to be a lot more finer. Most of that stuff, they're running it through these systems to literally beat that polymer up. And everything else that's kind of attached to it just ends up getting pulped. So you end up with sand, or you end up with, a paper pulp, or you end up with, metal shavings.
What about containers with oil?
I'm glad you asked. So then you have a hot wash system that's right next to it. So your hot wash, it's going to have, you got to integrate a boiler, right? And you have to have steam. Yes, sir.
One of my questions dovetails.
Hand on the microphone.
Oh, I didn't know there was going to be good questions. I like that.
Well, coming to the end of the hour, one of my questions dovetails on what he asked. A lot of your comments have centered around source material for you. What about plumbing PVC conduits? Is that recyclable?
Oh, yeah.
And my second question is just asking your opinion with electric vehicles. What percentage could you speculate in the future, what percentage of electric vehicles will have a subcomponent that you could recycle? Anybody
Right.
guess?
One of the companies that we deal with, Bay Polymers, that's in California, that handles Tesla. And so they take in a lot of the parts from Tesla, they grind them up, they pelletize them, they send the raw materials back to Tesla. So there is a lot of non-critical parts in the automotive industries that are actually integrated into recycled goods. So normally it's a portion. So you're not going to run 100% recycled product into a door panel or something. But what they're doing is let's call it the side moldings, right? So the side moldings are TPE, thermoplastic elastomer. So they'll take that scrap, they'll pelletize the scrap, they'll match the color. So if that's gray, they'll keep the gray, they'll keep all these separate, they pelletize it, they send it back, and they use that recycled material back into their prime mix at, say, 15-20%. So they're integrating it back in. The material's not going to the landfill. That's one of the landfill diversions, and they're reusing the material. And more and more products are getting automotive approval. So anytime that you have parts under the hood, whatever it happens to be, you've got to have an automotive approval for your raw materials to be able to be used to make those parts. And so the big push now, which is great for our industry, is that they are doing a lot of the approvals. It used to be, it took forever to get approvals for anything, but if it's recycled content in it, then they're pushing it through. And I think that's really kind of some of the advantages that's kind of happened in our industry, is that people want we want that product in there. So
salvage cars now are part of your feedstock.
I'm not in the material side anymore. I used to be. Right now I sell equipment, so I do turnkey systems for people that want to do recycling or want to do what we call upcycling, which is making a recycled content compound. So in that analogy for Tesla is, that guy's making a recycled content compound. And so to kind of go back to the hot wash system, so you got to have something that's heat, that you're going to have some surfactants, you're going to have some other things in this mix to be able to remove that oil, to remove the grease, to remove. Right, so there's quite a few different products, and a lot of them are going to be proprietary. So there's plenty of blends that are out there. I mean, I could guesstimate, some of them they're using, but a lot of those recycle, people are really proprietary on how they actually do it. But this is the equipment they use to do it. So it's basically agitators. You have hot steam that goes in, and you're cleaning it with hot, and it's taking the oil. Not all the odor, however. So that kind of goes back to having some kind of odor abatement where you have a vessel that you're deodorizing the material basically. Here's some examples of material separation. So this is for a hydropulp system. So hydropulp is for coated paper. So when they have polymer coated paper, this is called your old milk cartons. Of course, they don't do that anymore, but the paper milk cartons, that was a poly-coated paper. A lot of the seafood industry still uses that poly-coated paper. This is used for that. So they pulp the paper out, and what's left is the polyethylene, which is a layer of polyethylene, and that polyethylene is then recycled, and it's being put into a lot of the plastic lumber. So the plastic lumber industry uses that hydropulp. Well, there's some others. Some of the pyrolysis systems are attempting to use the hydropulp as well. You're basically between these two. You're trying to separate, in essence, bulk densities, right? So you've got something that's heavier and you've got something that's lighter, and so you're kicking these materials up, right, for the heavier stuff to fall down. So that's kind of that process of material separation. I'll go quickly through this. These are two examples of extruders. So the one on the top is one of the machines that we, our technology, and that's the ram-fed extruder. So this is a ram. You've got material that falls in the very top of it, polyethylene film, trash bags, what have you, non-woven polypropylene, so the stuff that comes in diapers. So that's a big industry, that the scrap coming out of diapers, not used diapers, but converted. And so you've got a ram that's basically cramming material onto a screw. So that technology, the advent of this technology is really what kind of revolutionized film processing, right? Because you've got a scenario where you've got a bulk density of, 10 pounds per cubic foot, and you're trying to extrude it. And so you've got to develop screws, so the depth of the root of the screws and the flights that the material can be able to, fall into at a rate in which is efficient. And so you've got to design this ram with the screw in mind, right? The second one is a co-rotating twin screw. This is a high vent machine. So a high vent machine meaning it's got multiple ports in which gases and moisture can be vacuumed out. So we put vacuum systems on these at different stages. So even if we're drying material, there's still inherent moisture in it, and when you're running some of these twin screws at 15,000 pounds an hour, you're still going to have moisture. You're still going to have inks, anything that's going to gas. Here's can't see it. And so these are the two melt filters. So this is what this screen goes. This goes to the one on the top. This is kind of the new technology, and this is what's created a lot of high quality end products that's changing a lot of people's minds in finished goods industry, right? That they can now get a good quality material and pellet through this process because of the fine filtration that you can have, right? So this thing can go all the way down to 80 microns, so it can get real tight. Basically the polymer goes, you can see that there's a inlet up at the very top. The material goes in, it sits like this. The material goes in here and seeps through that screen, and there's a a wiper that goes around that scrapes all the contaminants off and the good polymers on the other side and gets evacuated. The second one is it's got more of a continuous, it's built for a higher level of contamination. It's got 2 screens on either side, so the polymer goes in through this side and seeps through both chambers. And it's got a screw, and the wiper kind of wipes all the material onto that screw, and the screw evacuates the contaminants out on a continuous basis. So the one on top, it kind of waits till the pressure gets to a certain level, and then it hits it to wipe it, and it discharges out. This one's kind of a continuous. And you know, these machines can run anywhere, you know, as high as 12,000 pounds an hour, and can operate at 300 bar pressure. So at real high pressure, which is totally what, you know, against historical, you know, technology, this is kind of what's really changed the framework. Most major companies and manufacturers have some sort of this type of equipment. All right, so here's an example of a full wash line. So you have the conveyor, you got this is a shredder. So it goes from large particles into a shredder that goes into a particle that's about 2 inches wide. You want it kind of big, so you know the finer sizes as you go farther down. Goes into conveyor, it goes into a float sink tank. So you got paddles, you got water that's filled in that tank. These paddles are kind of beating this thing up and submerging it underwater. You've got 2 different materials. Mainly these are for polyethylene, polypropylene. That material floats, so it's less than 0.1, so it all floats. So your polyethylene's roughly between 920 and 960, and your polypropylene is 945 to 980. Unless you got fillers, calcium talcs, there's a lot heavier specific gravities, and so all of a sudden you can get into where it's higher than 1 and the material wants to sink. Then you got a friction washer. We sold a picture of the friction washer earlier, and then goes back into another. So they do multiple systems, right? It's not just the first one. You're knocking just kind of the basic contaminants off, and as you go down the line, you're getting a better, higher quality of raw materials. And then the last one is, here I'll show the, well, we'll come back. You know, when you're dealing with wash and dries and you got these paddles and you got all water, you got to do something with the water, right? You got to be able to treat the water. So there's water treatment is a big issue in our industry. Not really issue, but it's something that is a big expense, right? Because you know, you want to be able to reuse the water. You're not a scenario where you're running clean water to supplant the used water, and obviously, you know, water treatment as far as some of the products, pesticides, things like that, you got to be able to treat it. So the one on the left is a solid bowl decanter for water. That's mainly for your solids. So it spins at a high rate, all your solids floats to the side, and it creates this vortex, a tube that extracts the water from your solids. The next one is just a vertical centrifuge. So the material starts at the bottom, spins its way at top. By the time it gets to the top, all the water is slung off and the good material comes out the top. Here's examples of a shredder. So this is the rotor on the shredder teeth. That's how you do your size reduction in all these processes, whether you're wash and drying the film or parts or pieces or your milk bottles. You got to first shred the material. These shredders got to be built to be able to withstand, yes? 5 minutes, sir. Okay. All right, well, these are grinders, same size reduction, and I'll, all right, so we'll close with advanced recycling. So, you know, how does these resin, how does this industry really create a scenario in which people want to buy recycled goods, right? Well, you got to be economic. and advanced recycling or pyrolysis oil resin, which basically through heating a polymer up without oxygen breaks down the polymer structure, creates oil. They take this oil, they re-crack it to create prime resin out of this oil. So this is considered a post-consumer resin, coming from film to the pyrolysis oil, back to the cracker, back to a prime resin. The new products, I think we kind of covered some of those with the automotive, that this industry wants new products. And as long as we get approvals and people want it, they're going to make them. So, all right. Well, I appreciate you letting me do my. Yes. Any last questions?
Yeah. For us non-chemical people, I take one of the beginning things. Your industry is essential because you're helping us reduce our carbon footprint, so we don't have to put oils to make plastics in the first place. Right.
Yeah, I mean, we got to treat these as raw materials. We got to treat these as a resource, and to understand that these materials that we use, whether they can be used over and over again, as long as we can look at it as a resource and not something that we're throwing away, then, I think it benefits the planet, greatly. Yes?
Is it to recycle things like PVC pipe and HDPE pipe?
The microphone.
Very easily. I just sold a mixer to a facility that processes pipe and window profiles. So that material, windows, is a very developed market, and as far as contamination and things of that nature, that's addressed. But the main issue with that material is you got to have a collection point in which there's enough volume for them to be able to pick up. It's the three pieces of pipe. Yeah. But the industry as a whole is very, very mature. All right, thank you. Thank you for having me. Yep.
On behalf of the chapter here.
Yeah.
Give you
All right.
gift.
I appreciate it. Thank you, Jesus. Yes. Thank you, Roger.
Thank you.
Yeah.
All right, folks, hang on.
We hope you enjoyed this presentation given at one of the Atlanta Metro Chapter meetings of the Georgia Society of Professional Engineers, an affiliate of the National Society of Professional Engineers. To find out more about us or to join us, check us out at gspe.org.